We're still working on exponential and log functions and solving them. And we have 213, 214, and 215 left, and that will be our next test. Then we'll be done with Unit 2, and we'll start Unit 3, and that will be trig, which is my favorite. Okay, so let's start with this first fact, that when you're working with an exponential function, if you have like bases, you can cancel them out and set the exponents equal to each other, like this example here. So we have an exponential function, right? That means you have an exponent, or an exponential function means you have a variable in the power. Sometimes you might be given like bases on both sides. Sometimes one of them has to be changed, sometimes both, and we've done this type of problem before. And what I can do with this 64 is make it a base 2, so like bases. So I can rewrite this as 2 to the x minus 5 equals 2 to the calculator, or whatever you need to do. 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. And once you have like bases, you can set your exponents equal to each other and solve that equation and get x is 11. Okay? So when we work with exponential functions, and I'll do another one with you in a minute, you're going to first try to see if you can get like bases. Okay? And then I'll tell you what you can do if you can't get like bases. Now, just like here, just like this, in exponential functions, if you have like bases, you can cancel the bases and set the powers equal to each other. Same idea with logs. If you have a log base b equals a log base b, meaning the bases are the same, you can cancel those out, just like we do with the b's, and you'll be left with u equals v, and you might have to solve this little equation. And that's what we have here. We have logs on both sides, and notice they're both common logs, log base 10. And just so you know, none of the problems working with logs will be given, if there's more than one log in the problem, they'll always be the same base. We're not mixing bases. That's not anything we have to do. Okay, so they'll always be the same. But what you want to do is clean up the problem a little bit. See how there's a number in front of the word log, a number in front of the word log. We're going to use our power property to get it to look like this. Notice in this little property, there's nothing in front of the word log. We're going to put the 1/2 on the x and the 2 on the second. That's the power property. So that's going to become x to the 1/2, which is the square root of x. Okay, so remember, an exponent of 1/2 simply means square root. So I would have log of the square root of x equals, and of course, 2 squared is 4. Okay, so I call that like clean up. That's just my little term. We had to clean up the problem a little bit before we could apply, where since the logs are the same, just like here, the bases were the same, we can set the exponents equal to each other. Logs on both sides, we have the square root of x equals 4, and then we can just solve that. And we know how to get rid of a square root. We need square, and our answer would be 16. Okay, so let's do another one of each of those before I move on to some different ones. Okay, so we have an exponential function here. Again, I know that because there's an exponent with a variable in it. But look, it looks a little different from the last one. There's an extra number. The base in here is 1/2. This 24, a base is 1/2. This 24 needs to be cleaned up. Just like we talked about here, we had to have the word log by itself on both sides. We didn't want a number in front. We need the bases by themselves. So we need base. So I need 1/2, and 6 could be considered a base, right? That's a 1. I'm going to divide. And I'm going to simplify 6 divided by 24, and I'm going to keep it in fraction form because my base over here is in fraction form. You want it to look the same. And so now I have it cleaned up, but I still don't have like bases. 1/2 and 1/4 are not the same. Not this kind of height, this kind of height. Okay, I didn't mean to smile. Okay, so 1/2 and 1/4. We can rewrite 1/4 as a 1/2. Let me show you. We can make it a 1/2 by doing it to the power of what? What power? 2. If you square a fraction, you're squaring the numerator. That'd be 1. Squaring the denominator, that'd be 4. So that's getting like bases. Once the bases are the same, we can set the powers equal to each other. And then this is x divided by 3. We'll multiply by 3 and get x equals 6. Okay? Like bases. Now, let me remind you something about logs that I didn't talk about with our first example, but we're going to start talking about. Logs are, there's some rules with logs, just a log in itself. The base will never be negative, and the number here will never be negative. In other words, you would never see a negative base. Doesn't matter what else is going on. That will never happen. Okay? Also, this number is not allowed to be negative. Okay? So when you have a log problem that's got a variable in either of those spaces, you have to think about what is x not allowed to be. Okay? And I'm going to come back to that more at the end. But looking at this, I do have a variable in this spot right here. And I know that x, it can't be negative, but it also can't be 0. So we just kind of simply say x has to be greater than 0. Now you'll see me put it like in parentheses because it's never going to be written there. It's like a thought. It's like, I just have to be aware of that, and I'll come back to that idea here in just a second. But you're going to see me talk about that a lot. All right, so this one is just like the one above it. We've got log base 3 on both sides. Let's clean it up a little bit by getting rid of the number out in front. Four to the third, put it in my calculator, I get 64. And remember, now, with like base logs, the same bases on both sides, we then can set x squared equal to 64. And x equals plus or minus 8. Easy algebra, right? Easy math. But you do have to remember that we have to respect the fact that the problem that we are asked to solve has a log or logs in it. And within those logs, there are variables. And we didn't know before what x couldn't be. We know now what x couldn't be, and now we know what x is. We didn't do anything wrong in this problem, but we did switch into like using algebra to solve a log problem. So we changed it from a log to, I guess you could call it, it's not an exponential, but an algebra problem. And we solved it right, but we need to know that this is considered extraneous. We cannot put a -8 where that x is. The only solution we would have would be this one. And I'll keep bringing this up in the next few problems. Okay? Now, I want you guys to understand that it doesn't mean any number, any x value can't be negative. In some problems, it might be okay. It's not an x that can't be negative, is we can't make either of these negative. And I'll come back to that idea here on the next page. And if you're wondering what that word is that I'm saying, I know you guys have heard it before. It's extraneous. So we're going to talk about that here again. So this problem is starting as a log problem. I see an x. X is unknown. Well, we're about to know. But I need to remember at the end that, okay, x has to be greater than 0, right? Because if I put any number in there that is a 0 or a negative number, we have a problem. Because times 4 is just going to keep it 0 or negative. Now, what's different about this problem is we don't have logs on both sides. So none of what we're doing today is really difficult. It's just noticing that no two problems look the same. And so you have to kind of think, all right, what is this problem? What should you teach me to do for that? So exponential, you're looking for like bases. With logs on both sides, we're going to clean it up and cancel. Now we have a single log, or just one log, on one of the sides. So what I want you to remind you of is we learned how to rewrite these in their other form. And that's what we're going to do here. We're going to start with our base 2 to the 5th equals 4x, but watch how I'm going to write it. Is that what I just said? 2 to the power of 5 equals 4x, which if you wrote it like that, it is not wrong. And please don't erase it or think you can't. I just want you to get used to seeing the way I write it, and you'll see in the key and stuff like that, is typically we try and put x on the left-hand side. It is completely not wrong to put it on the other side. But if I didn't bring that up, you guys would start thinking, not you guys, but people would start thinking they were doing it wrong by having it written the other way. Are you sure I can do this? Okay, if it's that urgent, go ahead. Okay, now I'm going to keep going. 4x equals 32, divide by 4, and x is 8. Is x extraneous or is it good? Good. Perfectly fine. If that were a negative 8 for whatever reason, I would say no solution, right? Because if I had a negative 8, that would have made a negative 32 there, and that would not be okay. But I didn't get any extraneous solutions in that problem. Okay? Here's another type of problem. I have 2 logs on one side. So let's review that. One log on the left, one log on the right, so logs on both sides, a single log on the left side, an expanded log on the left side. These problems are almost identical with one extra step in the beginning, and that is to use our properties of logs to make it into a single log. Remember this, this property? When you have a plus in between 2 logs, you can rewrite it as multiplication, right? With a plus in between, we write the word log base b once and do m times n. And that's what we're going to do. I'm going to combine them and then multiply those 2 numbers together. So I'm going to have log base 10, right? It's a common log. And then when I do x times x plus 15, I get x squared plus 15x. Now these problems are the same. I have a single log on one side. Okay? So really these are the same. And now we'll rewrite this in its other form. So again, sometimes I tell you guys to start, and it's not wrong. You could write 10 to the second equals all of this, but I'm going to start trying to keep my x on the left-hand side. Remember where the 10 came from. This is a common log, so whenever we don't see a base, we know it's a base 10. So 10 squared is 100. And this is a quadratic, right? Not linear, 4x to the first. This is x to the second. So I'm going to bring everybody over to one side together. And then what do you think I'm going to tell you to do? Factor. This is a chart problem, or however you want to do it. I'm not going to review it. I don't need to see a chart, and I'm not going to go over it a bunch of times. But as a reminder, what 2 numbers multiply to go into negative 100, multiply to get negative 100, and add to get 15. 20 and 5, 20 and negative 5. And set those equal to 0 and solve. We get 2 solutions, negative 20 and 5. Now before I put a box around them or go to my answer sheet on my test and write them, I'm going to make sure that neither one is extraneous. So let's go back to the original problem. And it has to be the original problem, okay? So in this, there's 2 separate logs here, so we have to look at both of their restrictions. In this first one, x is just greater than 0, right? We can't put a 0 there. That's why we didn't put equal to, and we can't have any negatives. But this one, what does x have to be greater than on this side? Negative 15. Where'd she get that from? Well, if I set that greater than 0 and solve it, subtract 15, x has to be greater than negative 15. If I put a negative 15 right there, I would get a 0. If I put a negative 16 there, I would get negative 1. If I put a negative 20 there, I'd get a negative 5. This one is more restrictive. So I know, all the numbers greater than 0 are covered here, right? So we have to respect both of them. So we can't have any numbers that are less than negative 15. And negative 20 is less than negative 15. solution is 5. But let me pretend that I got, what if one of my answers, let me make one up. Let's pretend that wasn't in there, and I got an answer of -7. Okay, so let's just pretend that this is the problem, and I got an answer of -7 is one of my two. Is -7 extraneous, or is it good? It's good. So it's not an x that can't be negative. It's when you plug it in, you can't get a negative. So -7 plus 15 would have been 8. So this would have been okay if that were the problem. It's not. Right? Good. We only have one more to do. Question on what I did? Yes. Mm-hmm. X can't be, well, you're saying it has to be greater than 0, because you can't have a 0 here. And I was say if that part weren't there. Okay, yeah. -7 wouldn't work if, yeah, for that one. All right. The last one we're going to do is this one. And we're back to exponential, right? How do I know it's exponential? The word log is in it, and it has a variable as the exponent. And so whenever you're dealing with an exponential, two things. First thing is, we don't care about positives and negatives, okay? Anything can be negative, fraction, it doesn't matter, okay? It's only logs that we worry about this extraneous thing. So that's one thing. And the second thing is you want to try to find like bases if you can, because the alternative method, which I'm going to teach you, is not that much harder, but it's more work. Okay, so when I look at this, I say, okay, let me get like bases with 8 and 26. And the truth is, it's not possible, okay? It's not possible, so we have to have another method. And before I tell you what that is, I want to remind you of a fact that's going to help you understand this, and that is this property. Does anybody remember what log base b of b would equal? 1. So log base 7 of 7, 1. Log of 10, 1. Natural log e, 1. Okay, don't forget, common log, we just know it's a 10. Natural log, always e. Always, okay? So these are really important. They pop up all the time. So now that I said that, let me tell you what we're going to do. Remember in algebra, you can do anything you want. I call it the golden rule. As long as you do it to both sides, you can do anything you want. Like, wait, add 5 to that side? Okay, we add 5 to that side. We take the square root of this side, we take the square root of that side. So what I'm going to do is give both sides a log base 8. I put that in red, and I'm going to put in purple, just so you can see what I did here. The original problem is now in purple. So 8 to the x minus 3 equals 26 was the original problem. And I put in log base 8 on both sides. Why did I do that? For this reason. So before I did that, I said, okay, where's my base? They're actually both bases, but which one has a variable in their exponent, and that's the 8. That's how I chose the base 8. So if this was 7 to the x minus 3, I would have chosen log base 7. Okay? And we'll do one in the homework together. The reason I did that was because, look, log base 8 of 8 is just 1. And with our power property, because now we are a log problem, I can bring x minus 3 down on the ground. Okay, so what you're going to see here is if I put log base 3 of 26 in my calculator, I'm going to get a decimal. This happens anytime I can't get like bases. When you are forced to use this method, you're going to get a decimal. So let me show you something. I'm going to add 3. And this is what we're going to call our exact answer. You might see me just write EA. And then we're going to approximate it. We'll put it in our calculator. So let me back up. If I had tried to solve this, log base 8 of 26, and I'll show you how to put it in your calculator again in a second, you'll see that you get a crazy decimal. So then I would say, oh, okay, let me write it 2 ways. Let me write it as, or depending what the directions tell you to do. If it was a non-calculator part, you would just stop right there. That's the final answer. But we can put it in our calculator and get a decimal. So Remember the log button right here is just base 10. Okay, so we're not a base 10, we're a base 8. So we hit math alpha math. Math alpha math. And then I'm going to just put the 8 there, arrow over to the 26, get out of the parentheses, that's important, plus 3. So it's kind of like when you've done like quadratic formula before in your life, just as one of many examples, or in geometry, when you write your answer in terms of pi, you leave pi in the answer, it's exact. Or round your answer to so many decimal places, you would do whatever the number is times pi. Quadratic formula, you get the answer of the square root of 17. Okay, they want you to leave it as an exact answer, or are we supposed to round it and then put it in our calculator? So it's the same idea, okay? Why am I not adding 26 and 3? Well, and that's a common mistake. That would mean that, so log base 8 of 26 is actually 1.5, okay? If I add 3 to that, where would I be getting 29? There's just no way to make that work. So just understand, it's just log base 8 of 26, and then plus 3. Okay, don't make that a 29. Does that make sense? We'll do another one in the homework. Okay, let's go to the homework. You might have noticed yesterday that our homeworks are labeled letter C now. And I'm going to do a bunch with you. So that last method I showed you where you had to, like, you couldn't get like bases, it's kind of like quadratic formula. You know how quadratic formula works on all quadratics, but sometimes you're like, why would I spend all that time when I can factor it in 2 seconds? And I'm going to show you what I mean. Number 1, have we all written it down yet? If you, that's not the problem. Whoops, I went a little too far. If you didn't know how to get like bases, you could use, and I'm going to show you this one both ways in just a second. So I'll come back to it. Do we have this written down? Okay. So I'm going to start by trying to get like bases. So 81, which you might have just seen, is the same as 3 to the 4th. Bases are the same. Exponents are the same. Done. But you also could have said, oh, I'll give both sides a log base 3. Again, why did I choose that? Because this base is 3. If I have the same numbers there, I would get x equals log base 3 of 81. If you put that in your calculator, you get 4. But what if it was a non-calculator portion? You would have to know that 81 can be written as 3 to the 4. And then that cancels and you get 4. So I would make sure you know both methods, but that's a good fallback if you really could not find like bases. Especially in problems like number 2, because we see fractions and people just get scared. Square fractions are scary, according to my idea. So like bases. So 5 and 625 is what we're going to look at. And you may realize that 625 can be a base 5. And you might not know that before, but you could pick up your calculator and certainly explore it. So 5 to the 2nd is 25, 5 to the 3rd is 125, and 5 to the 4th is 625. Okay? Now, 5 and 1/5 are not the same number. Like x does not equal 4, okay? X does not equal 4. But we learned, and talked about this a lot last semester, that we can make this 1/5 into a 5 by bringing the 5 to the top. And when we do that, it changes the sign of the exponent. So remember, whether you go from top of a fraction to the bottom or bottom to the top, it just changes the sign of the power, okay? You can go in either direction. And now our bases are the same, and x equals -4. Good? Question? So hopefully you guys are doing this with me. I'm doing homework problems with you. So look at, there's a 2 and there's a 64. Let's pretend it's a 2 and a 64. We'll fix the fact that there's a fraction later. Can I make a 64 into a base 2? And the answer is yes. 2 to the what is the question. So 2 to the third is 8, 2 to the 4 is 16, 2 to the fifth, 32, double it again, we get 64, so that's 2 to the 5th power. 6th power, sorry. 2 to the 5th is 32. 2 to the 6th is 64. And so I can make this 1/2 have the same base as the 2, the same way I just did with this one. I'm going to bring the 2 to the top. What's that going to do? It's going to change the 2's, well, I don't even like saying it like that. Forget I even said that 1. I mean, there's a 1 there, but 1 times 2 is 2. It's going to change the power of the exponent. So when I bring this 2 up, it just becomes, is that an x? Sorry. It's going to make my x negative. That's it. The 2 joins the 1, changes its power, and that is his power. Right? The parentheses, that x goes to the 1 and the 2. Equals 2 to the 6th. Can an x be negative in an exponential function? Yeah. Just not in logs. Well, for the reason all that Sally was talking about. Another exponential, it's got some cleanup going on. Right, that 5 needs to get out of there. We can divide both sides by 5. And when I put 175 divided by 5 in my calculator, I get 35. So we have this exponential function. We want to get like bases, but you don't need to waste a bunch of time looking for it. There aren't any bases that they can both become. I can't even change both of them to have a like base. So this is where I'm going to give both sides a log with the same base as this, which is a common log, right? Log base 10. So I'm going to put a log on both sides. If you want to write the 10, you can. Don't need to. Right. Golden rule of equations. When I do the one side, I do the other. That cancels. X comes down. That's my exact answer. And now I can put it in my calculator. You can use your quick button, which is quicker, because that's a common log, log of 35. But you could use the other one, math, alpha, math, but you would have to type in the 10. But you get the same answer either way. $1.544. Okay, so exponential functions, we don't worry about negatives. We try to get like bases if we can. If not, we give both sides the log. Although this method works for all of the above problems. Okay, skipping to number 7, I want to do some logs with you. Feel free to leave me behind if you're super confident here. These are the ones you do have to respect the fact that the base and this number can never be 0. And since we have a variable in one of those two places, we have to kind of be thinking. And like I said, you'll never see this written out. So you'll see me kind of write it in parentheses. It's kind of like it's in my brain. I'm just kind of keeping it in mind. And whether you write it, think about it now, think about it at the end, just think about it at some point. Okay? It's just make sure you're aware of it. We don't have logs on both sides. We only have one. And so I think you have your hand up, So whenever there's just one, we're just going to rewrite it in its other form. So I like to keep my x on the left-hand side, so it worked out nicely in this one. And just like when you have an x squared, we do the square root. If you have an x to the fourth, we do the fourth root. And anytime you take an even number root of a number, you're going to have two solutions, okay? So you have to remember the plus and the minus here. And when you do the cube root of 625, you have to put the 4 on your screen first, and then you go to math. Number 5. See how it has an x there? We already told our calculator we want that x to be a 4, so you have to put the 4 in first. Yeah, 5. Are either one of those extraneous? Are either one of those going to be a problem? Yeah? Yeah. The negative, right? So the only answer in that problem is the positive. We can't have a negative 5 right here. X has to be greater than 0. Now I stopped at 7 with some classes, and I went on to 8 and 9 and others, and so I think they appreciated me going on. So I'm going to keep going, especially because we haven't really done a natural log one, I don't think. And I just want you guys to understand, don't be scared of a natural log. Everything's the same. The only difference is you get a base E. That's it. Like this problem 8 is just like number 7 with some cleanup in it. Okay? We could put the 5 on the 2x, but it makes it kind of messy. Or you can divide by 5. And now we just rewrite it in its other form. E to the 4th equals 2x, or 2x equals e to the 4th. Anytime you're dealing with an e, unless it's like e to the 0 power, yeah, you're going to get a decimal. Anything with 0 power is 1, right? But anytime you're dealing with e to the other, so if you put e to the 4th power in your calculator, you're going to see you get a negative. So I'm just going to go ahead and give my two answers. X equals, sorry guys, x equals e to the 4th over 2. That would be an exact answer, and then we can put it in our calculator and get a decimal answer. Just depends on what the problem is asking for. Your E button is above natural log. So second natural log to the 4th divided by 2. Okay, like I said, this will be my last one. Oh my goodness, there's natural logs everywhere. We've got logs all over the place. We've got a expanded log on the left and a log on the other side. Well, one thing we know we can do is combine these, right? Plus and multiplication go together. So I'm going to write it as a single log, natural log. And when I do x times x minus 4, if you need to go off to the side, I'm just distributing. I would get x squared minus 4x. And so this is, we like these. We don't have to rewrite it in its other form. We don't even need to worry about the base e. We have the same log on both sides. So we have a quadratic. So I want to get everybody on one side together and factor it. Two numbers that multiply to get negative 5 and add to get 4. Negative 4. We get two solutions. Algebraically, are they both okay in our final answer. And sometimes the answer is yes, remember. There's not always extraneous solutions when you have two. But you can see x has to be greater than 4, x has to be greater than 0. This one's more restrictive. These numbers are covered here. Right? These aren't, all the numbers greater than 0 are also greater than 4. So 5 is fine. Okay. All right, I did a lot with you. Keep on going, you got lots of time.